Hello, we are PBVar and welcome to our final video presentation. So what is PBVar? Say you and your friend are playing pickleball and you hit the ball inbounds but your friend says it's hitting out of bounds. Now this can lead to a heated debate, but since you have the new PBVar app, you now have a third eye that can tell you if the ball landed inside or out with an audible noise. Now this alleviates any game call questions when you're playing pickleball. Whether you're a casual user or a competitive player, anyone can be utilizing PBVar in making sure their games are accurately called. Not only does this give you live game calls, but then you can go and see your previous games through a recording and a stat sheet to show you where your shots were and all the stats for the game. This allows all players of pickleball to improve their game and enhance their experience. And now I will hand it off to Ethan to demo the app functionality.
Hello, welcome to our PBVar final functionality demonstration. So when the user opens the app, they're going to be greeted with a sign in and sign up page. So we're going to enter Ethan at test.com just as an example. The user is also free to create new accounts as they please. After the sign in page, they are greeted with a permissions page where they have to enable camera, microphone, and library access in order to store all videos in the app. When the user opens the app, they're directly greeted with the camera screen. So this is where they can record pickleball games. So they first scan their pickleball to get the accurate color. They then drag the courts the correct locations. So this is just an example. So we're not actually showing a pickleball court, but they would drag those to the corners. And then after that, they're all set for tracking. So as you can see on the screen, there is a ball that is bouncing across, and every single bounce is tracked with a green X. The first one that goes out is a red X. And the last one that goes out, or the ones preceding, are all white X's. So here's our stats page where we have a whole bunch of stats for ins, outs, and also heat map, and also a video playback feature. So the user can use this after their games to go review it, and we'll also review their teammates' stats. So right here, I'm uploading to Firebase. I'm also showing that we can delete it and then repull from Firebase. Firebase also includes all the original stats the user kept and tracked during their game, as I'll show right now. So it has the original stats, the original map, and the original video playback. And so users can store all videos locally and in the cloud as they please. It's really up to them. Lastly, just walking through our settings page, users can edit their account settings, so change the password and delete it. They can also edit the FPS, the resolution, the sound, and they can also hide the graphics on the screen for better performance in the actual application. Lastly, they can change their name and profile picture, and they can sign out of the account.
Thank you, Ethan. Now I'll hand it off to Aleko and Andre to talk about our front-end tech, our back-end tech, and also the engineering workflow and user study.
For our front-end tech stack, we went with React Native with the Expo build framework and Firebase Auth cloud storage and Firestore. We chose the Expo framework for ease of native development for Android and React Native Vision Camera for working with our back-end frame processors. We went with Firebase for its easy integration with authentication across cloud storage and Firestore for storing games in the cloud unique to each user.
We leveraged React Native's fast open CV library because it allowed us to write custom C++ functions, which we use to do ball detection, bounce detection, court alignment, and transformation. The backend also includes a game model, which is used to communicate computer vision results to the front end.
We utilized an agile workflow with weekly Scrum meetings with a sum of 82 issues over 16 weeks, committing about 230 times to the main repository. For our user study, we conducted it on 12 people. A third were OpenCV exclusive, and everyone reviewed our UI. From this, we altered the UX flow and added some new features based on user feedback.
Thank you, Andre and Aleko. Finalizing our presentation, I would like to take a minute to talk about how we split up our work. Now, given there was a full stack application side and a computer vision side to this app, we split into two teams, with myself and Aleko on the full stack app side and Andre and Ethan on the computer vision side. Now, given the differences between these two sections of the app, this made it a lot easier to get to our development goals within the time frame that we had. With our weekly Scrum meetings, however, we all stayed pretty up to date with what everyone else was doing in the app. This made it so when the time came to integrate the CV side and the full stack application side, everyone was already caught up on what each other's code does. Now, though there were definitely some unexpected challenges, having this separation of concerns with the full stack side and the CV side made it so we had two team members who could specialize in different parts of errors that we found, whether it was on the CV side or the full stack side. Looking back, this was a critical decision to split up the team in order to reach our goals before demo day. We appreciate your time for watching our final presentation demo, and we hope you enjoyed.